we are going to refresh quickly the concept of concentration of different hydraulic systems in your boat in a central hydraulic unit. The central hydraulic unit, like I explained yesterday, is composed by the container or reservoir, the servo valves, the motor, and the pump. That's it. And the motor could be AC current or DC current. However, suppose that you have a central hydraulic unit with an electric motor, AC or DC, and for some reason you don't have electricity, AC or DC, but you have a backup normally in the boat, a mechanical backup. The mechanical backup is another pump, other mechanical pump connected to the gears of the crankshaft and camshaft of any of the engines. That pump is this. This is the gear, and this is the gear that is connected with the crank and cam, and those are the outputs, input and output, the hydraulic lines. And that's it. What is the name of this pump? PTO. And where is connected in the motor? I'm going to show to you right now where will be connected. You see, guys, the plate? The majority of the diesel engine, the majority no, all of them, they have a plate like this. And in that plate, you bolted the pump. If the pump is bigger, you create an adapter. But this is the position. And is this gear engaged with the other train of gears. And right now the pump is running with this engine, with the other engine, with this generator or the other generator. The PTO. That the PTO is engaged here with the main engine or with a generator.
Where would that go?
Excuse me?
Where does it go?
Yeah, that one enter here. I remove the plate and engage with it. That's the PTO.
Can you have more than like one input, one output, or do you?
No, this is one input and one output. And now, let me explain where will be connected the input and the output. Let's go. Okay, guys. That's the PTO. Nice, no? It's very common in marine applications. Find one of those pumps in any of the engines or in any of the generators. And this is the backup for the main system. For example, look at this system. This system is composed for the electric motor, the pump, the reservoir. Okay, from the pump, you have one supply manifold and one return manifold. And now, from this supply manifold, I connect here the gauge, the pressure gauge, and this is the return manifold. From this one, I am going to activate actuators or motors, any hydraulic equipment that I wanted. How many? In this particular case, 4, but I can install a bigger manifold. The pressure here depends on the pressure produced for the pump. And the pressure produced for the pump is the pressure that we calculated yesterday. You remember yesterday? We are going to create a table. In the table, we are going to put the system, the pressure in PSI, the flow in gallons per minute, gallons per hour, and the head in meters or feet. And you say, for example, the David, the pressure is 60 PSI, and the flow is 1.5 gallons per hour, and the head is 6 feet. You have the pasarela, it's 40 PSI, it's 1.2 gallons, and it's 3 feet. The other hydraulic system is for the garage door. It's other 40 PSI, 1.5 gallons, and other 2 feet. And you have more, and you add it. And in total, you say that I have in total 300 psi. And the flow is the flow in total is 10 gallons per hour, and the total head is 25 feet. Okay, with this information about the pressure, about the flow, and about the head, you select the pump in internet. This is the hydraulic pump that I need. Okay. Now, with that pressure and that flow, you can calculate the horsepower. You remember? What is the formula to calculate the horsepower that I need in the motor, in the electric motor? Horsepower is equal to the flow times the gallons, the pressure times the flow divided by the constant. How much is the constant?
1714.
1714. With that expression, how much is that? Is 3,000 divided 1714. Okay, is 1.75 horsepower. In other words, this is a motor of 1 3/4 horsepower. Nice. Okay, and you said, okay, I need a 2 horsepower motor. What is better, single phase, double phase, 3 phase? 3 phase will be better if I have 3 phase in my boat, or 2 phase if I have 2 phases in my boat. Oh, let me check the panel of my boat. I have 2 phases. Okay, I need a 2 phase motor. No, I need a 2 phase motor, 2 horsepower. Okay, let me I do the analysis. Suppose that I have in my boat double phase. I need 1 3/4. I am going to approximate to 2 horsepower. Let me know how much is 2 horsepower in watts. 1 horsepower is equivalent to 746 watts. 2 horsepower is 1500 watts. Is 1.5 kilowatts. Yes or not? Okay, 1.5 kilowatts. This is the power of the motor, of the electric motor that I need. Okay, let me check. I have a 1.5 kilowatts. This is the power. Is equal to the voltage times the intensity. The voltage, because my boat is double phase, is 240 times the intensity. This is the intensity that I want to know to select the breaker. All right, I have a 1500 watts divided by 240, and this is the intensity. How much is 1500 divided by 240? 6.25 amps. I am going to use a breaker of 10 amps. Bingo! I have the breaker, I have the capacity of the motor in kilowatts. I have all the information that I need for my hydraulic system. I know the capacity of the pump, 300 psi, and the flow, 10 gallons. I need a motor of 1.5 kilowatts, double phase, and I need a breaker of 10 amps. Bingo!